going deep into the world of Srinivasa Ramanujan.
Oh, a fascinating choice.
A mathematician,
Yeah.
but with a story so incredible, it feels like we're stepping right into a mathematical mystery novel.
I mean, it really is remarkable, right? This is a young man
Yeah.
from early 20th century India,
Right.
a time and place where access to advanced mathematics,
Right.
was very limited.
Yeah.
And yet he makes these discoveries that still have mathematicians today,
I know.
over a century later.
A century later, still
Just ripples
going out.
through the mathematical world.
And here's the thing.
Yeah.
The most fascinating part is he claimed these complex equations
Yeah.
came to him in dreams.
Right. Like,
Divine inspiration, And here's the kicker.
yeah.
Modern mathematicians are proving some of these dream equations
It's incredible, isn't it?
to be true.
It's what makes Ramanujan such an enigma.
Yes.
I mean, his work just goes beyond, just your typical, solving problems.
Okay.
It challenges how we even understand where these brilliant insights come from.
Yeah.
So to really kind of grasp this,
Yeah.
we need to start at the beginning with his upbringing in colonial India.
Okay, so paint the picture for us.
Yeah.
What was life like for a young, mathematically gifted mind
Right.
in India at that time?
All right, so imagine this. Ramanujan,
Okay.
born into poverty,
Okay.
limited access to formal education,
Right.
but possessing this unquenchable thirst for mathematics.
He just loved it.
He loved it. He devoured any math book he could get his hands on.
Wow.
He even taught himself from, an outdated encyclopedia.
Really?
Oh, yeah. I mean,
It's like the classic underdog story.
It is. It is.
Except instead of a sports field, it's the world of these abstract mathematical concepts.
Exactly. And just like a dedicated athlete, right?
No, right.
Honing their skills, Ramanujan just practiced relentlessly.
Wow.
I mean, he even failed out of college twice.
Really?
Oh, yeah.
Because of math.
Because he was so dedicated to mathematics that all the other subjects,
Yeah.
they just fell by the wayside.
Yeah, relatable.
It's relatable, right?
Yeah.
But that single-minded focus allowed him to develop these very unique approaches to,
Okay.
numerical patterns and properties. So he really forged his own path in the world of numbers.
So we have this self-taught prodigy
Yeah.
with these groundbreaking ideas.
Right.
How does he go from, obscurity in India
Right.
to the heart of the mathematical world? How does that happen?
So by 1912, Ramanujan realized,
Yeah.
his work, it was too revolutionary to keep to himself.
Right.
So he did what any ambitious young mathematician would do.
Yeah.
He started sending his findings to the leading mathematicians of the time,
Oh, wow.
including some big names at Cambridge University.
I can only imagine what those esteemed professors thought
Oh, I know.
when they received these
Right.
complex, unorthodox equations
Yes.
from a completely unknown,
Right.
uncredentialed individual in India.
In India, what? Yeah, and you're right. Most of them dismissed him
Yeah.
because his work was so unconventional.
Yeah.
It was lacking formal proofs. It was
Yeah.
really steeped in intuition.
Right.
So they struggled to grasp its significance.
I could see that.
It's understandable, though. They were looking at it through the lens of established mathematical tradition.
Right.
And here's Ramanujan presenting something totally new.
But thankfully,
Yes.
not everyone overlooked his brilliance.
Thankfully, no.
There was one mathematician who saw the potential in those equations.
Yes.
G.H. Hardy, right.
G.H. Hardy, exactly.
Yeah.
A leading figure at Cambridge,
Right.
renowned for his rigorous traditional approach to mathematics.
Yes.
Yet even he was struck by the sheer audacity and originality of Ramanujan's work.
Wow.
He later wrote that the formulas were so outlandish,
Yeah.
so mind-bogglingly complex that they had to be true
Wow.
because no one could have just invented them.
Like they had to come from somewhere.
Yeah.
Correct. Wow.
It's like stumbling upon a lost symphony written in a musical language
Yes.
you don't understand. But the sheer beauty and complexity of the composition
It's got to be something.
tells you this is special.
Right.
This is something special.
It's not just random notes.
Exactly.
Yeah.
So, intrigued, Hardy initiates this long-distance correspondence with Ramanujan.
Really?
Oh, yeah, exchanging letters filled with mathematical ideas.
Wow.
And over a year, this back and forth,
Right.
Hardy really recognized the immense potential
Yeah.
in Ramanujan's very unorthodox methods and insights.
Yeah.
He saw a diamond in the rough and knew it needed polishing.
And so we brought him to Cambridge?
So with some effort, he arranged for Ramanujan to come to Cambridge.
Wow, I can't imagine, that
Yeah.
transition from rural India
Right.
to the hallowed halls of Cambridge.
Oh, yeah.
Must have been a massive culture shock for Ramanujan.
Absolutely. I mean, the cultural differences,
Yeah.
the formal academic environment, even the dietary restrictions due to his religious beliefs.
Yeah.
It was challenging,
Yeah.
to adjust.
Right.
But despite these hurdles, their collaboration blossomed.
Okay.
But even then, there was a clash of styles.
Right.
Ramanujan was accustomed to working very intuitively.
Right.
And he often struggled to provide the rigorous proofs
Okay, yeah.
that Hardy, who was this champion of formal mathematics,
Right.
he demanded those.
So you have this fascinating dynamic.
Yeah.
You have the intuitive genius from India,
Yeah.
and then you have the rigorous traditionalists from Cambridge,
Right.
and they're trying to find common ground.
Yes.
So what happens next? What happens next with these two?
Well, there's this remarkable story
Okay.
about two particular statements that Ramanujan was struggling to prove.
Okay.
He was totally convinced they were true,
Okay.
but he couldn't quite demonstrate it formally.
Okay.
And it turns out he was right. But the proof had already been discovered, hidden in plain sight.
Wait, so someone else had already proven these statements?
Yes. Unbeknownst to both Ramanujan and Hardy,
Wow.
a little-known mathematician named L.J. Rogers had published these exact proofs
Oh, wow.
20 years earlier.
No way.
His work was so obscure it had gone largely unnoticed
Oh, wow.
by the mathematical community.
Wow.
It was only through Ramanujan's intuitive leap
Yeah.
that Rogers' work was rediscovered and its significance recognized.
So Ramanujan, without even realizing it,
Yeah.
stumbled upon this hidden gem
Yeah.
in the vast landscape of mathematical knowledge.
Exactly.
That's
In
incredible.
that gem, those two seemingly obscure statements
Yeah.
would form the foundation for something truly remarkable, the Rogers-Ramanujan identities,
Okay.
which would become a cornerstone of Ramanujan's legacy
Right.
and a source of fascination for mathematicians for generations to come.
Okay, now you've piqued my curiosity.
Yeah.
We've talked about the backstory, the drama,
The drama.
the rediscovery.
The rediscovery.
But what are these Rogers-Ramanujan identities? And
Yeah.
why are they so important?
So at their heart, the Rogers-Ramanujan identities are these equations
Okay.
that connect two seemingly different concepts,
Okay.
infinite sums and infinite products.
Okay.
And they reveal a hidden relationship between addition and multiplication.
Right.
But more importantly, they provide a key to understanding the world of partitions.
Okay, let's break this down a bit.
Sure.
I think infinite sums and products might sound a little intimidating.
Yeah.
And I'm guessing our listeners might be feeling the same way.
Yeah.
So is there a way we can kind of visualize this?
Think of it like this. Imagine a pie.
Okay.
You can cut into an infinite number of slices.
Okay.
Each slice, no matter how small, is still part of the whole pie.
Okay.
So an infinite sum is like adding up the values of all those infinitely small slices.
Right.
An infinite product is like multiplying them all together. So the Rogers-Ramanujan identities tell us that under certain very specific conditions,
Yeah.
those two seemingly different operations can actually lead to the same result.
Okay, I think I'm starting to get it.
Yeah.
But I'll admit, my brain is still doing a bit of a somersault trying to grasp this concept of infinity.
It's a big concept.
But you mentioned something about partitions.
Yeah.
What role do they play in all this?
So this is where it gets really interesting.
Okay.
A partition is simply a way of breaking down a whole number into smaller parts.
Okay.
So for example, the number 5 can be partitioned in 7 different ways.
Okay.
5, 4 plus 1, 3 plus 2, 3 plus 1 plus 1, 2 plus 2 plus 1,
Wow.
2 plus 1 plus 1 plus 1, and 1 plus 1 plus 1 plus 1 plus 1.
Okay, so all those different combinations.
Right. And the Rogers-Ramanujan identities give us very specific rules for creating these partitions.
Yeah.
And then they show us that if we follow those rules, the number of possible partitions will always be the same, even if the rules themselves
Wow.
seem totally different.
That's amazing.
It is, right?
So it's like saying that there are multiple paths
Yeah.
to the same destination,
Yeah.
even though those paths look completely different on a map.
Exactly.
Yeah.
And the beauty of the Rogers-Ramanujan identities is that they don't just give us one set of rules. They
Right.
give us multiple sets of rules,
Okay.
each leading to that same count.
Wow.
So it reveals these hidden symmetries and patterns within the world of numbers.
So as fascinating as this is,
Yeah.
the story doesn't end there.
It doesn't end there.
There's more.
There's
Oh, man.
more. The true impact of these identities extends far beyond the realm of partitions.
Okay. Before we go there, though,
Yeah.
let's just take a moment to appreciate the journey so far.
Okay.
We've gone from a poverty-stricken, self-taught prodigy in India
I know.
to a groundbreaking collaboration in Cambridge
Yes.
to the rediscovery of a lost mathematical treasure.
It's amazing.
And now we're about to explore the far-reaching implications of these mysterious identities.
It's quite a tale, isn't it?
It is.
And the adventure
It really is.
is just beginning. Hold on tight.
Okay.
Because these Rogers-Ramanujan identities are about to take us on a wild ride through some of the most unexpected corners of mathematics.
I am ready. Listeners, stick with us because this deep dive is about to get even more fascinating.
Oh, yeah.
So we've established that the Rogers-Ramanujan identities are these fascinating equations connecting infinite sums and products.
Right.
And they reveal these hidden patterns in the way we can break down numbers.
Yeah.
But you hinted that their significance goes way beyond that.
It does.
What makes these identities so special in the grand scheme of mathematics?
Well, what's truly remarkable is that the Rogers-Ramanujan identities, they don't just live in isolation. They have this uncanny ability to pop up in seemingly unrelated areas of mathematics.
Okay, so it's not just about partitions then.
Yeah.
Where else do these identities show up?
Okay, hold on tight because we're about to go on a whirlwind tour.
Okay.
We're talking statistical mechanics.
Okay.
Where these identities help us understand how particles behave in large systems.
Wow.
Then there's representation theory.
Okay.
Where they provide insights into the structure of abstract algebraic objects.
Right.
And even knot theory.
Knot theory?
Yes. The mathematics of knots.
Wow.
Uses these identities to explore the intricate ways we can tangle and untangle loops.
That's a lot to unpack.
It is.
So it's like these identities are a universal language spoken across different mathematical disciplines.
That's a great way to put it. It really is.
Yeah.
Each time these identities appear in a new field, it's like discovering a hidden passageway connecting seemingly separate rooms in a vast mathematical mansion.
Ooh.
And each new connection provides a deeper understanding of both the identities themselves and the field that they've kind of illuminated.
Okay, so we've established that the Rogers-Ramanujan identities are like mathematical celebrities.
Yeah.
Making appearances in all sorts of different fields.
They really are.
But what about their impact on modern mathematics?
Yeah.
Are mathematicians still actively working with them today?
Absolutely. In fact, Ramanujan's work, particularly these identities, continue to inspire cutting-edge research.
Wow. Okay.
So let me introduce you to Hussein Mortada.
Okay.
A mathematician studying singularities.
Singularities. Now refresh my memories.
Sure.
What are those again?
Okay, so think of a singularity as a point
where
a geometric shape takes a sharp turn.
Okay.
Or where different parts of a shape intersect in an unexpected way.
Okay.
Kind of like a wrinkle in the fabric of space.
All right. Yeah, now I'm picturing like those 3D computer models.
Yes.
With all the strange curves and folds.
Precisely.
Okay.
So Mortada and his colleagues were studying a very simple singularity. You know, something like a starting point in their research.
Yeah. Okay.
And as they delved deeper into its properties, they stumbled upon something truly remarkable.
Ooh.
The Rogers-Ramanujan identities.
Wait, seriously?
Yes.
The Rogers-Ramanujan identity showed up there too.
I know, right?
What's the connection?
It's a bit complex.
Okay.
But essentially the way this very simple singularity behaved mirrored the patterns described by the Rogers-Ramanujan identities.
Wow.
So they were staring at a geometric representation of those numerical relationships.
Wow. Okay.
Mortada was so ecstatic about this discovery that he literally danced on his desk.
He danced on his desk.
Danced on his desk. Wow! I mean, who wouldn't?
I guess not.
Right. It was like finding a hidden message from the universe encoded in the very structure of space itself.
Okay, now I'm starting to get why mathematicians get so fired up about this stuff.
It's exciting stuff, isn't it?
It really is. You know, it's like they're on this constant treasure hunt.
Yeah.
Seeking out these hidden connections between seemingly disparate mathematical concepts.
Exactly.
And the Rogers-Ramanujan identities.
Yes.
Are like a master key, unlocking doors to new discoveries.
That's a great analogy.
Yeah.
And for Mortada, it wasn't just a moment of celebration. It was a launch pad for a decade of further research.
Wow.
Inspired by this unexpected connection.
Right.
He and his team have uncovered a whole new family.
Wow.
Of partition identities.
Really?
Expanding on Ramanujan's original work.
Wow.
And pushing the boundaries of our understanding even further.
It's amazing how Ramanujan's legacy
Yeah.
continues to ripple outwards, inspiring new discoveries and new generations of mathematicians.
It's amazing.
But we've talked a lot about the theoretical beauty of the Rogers-Ramanujan identities.
We have.
What about their practical implications?
Yes.
Does all this abstract mathematical exploration
Yeah.
have any real-world applications?
This is where it gets really exciting because just this year,
Oh, okay.
in 2024,
Yeah.
mathematicians made a groundbreaking discovery using partition identities.
Okay.
They developed a formula that can detect prime numbers.
Wait a minute. Prime number.
Prime numbers.
Like those are the building blocks of multiplication, right?
They are.
How can partition identities, which are all about adding things together,
right,
be used to find prime numbers?
It's a fascinating paradox, isn't it?
It is.
But that's the beauty of mathematics, its ability to reveal connections between seemingly unrelated concepts.
Right, right.
So this new formula, while complex,
Okay.
hinges on this intricate structure revealed by partition identities.
Okay.
It leverages the way we can break down numbers into their constituent parts to identify those special numbers that are only divisible by one and themselves.
Okay, I'll admit I'm still trying to wrap my head around how that's even possible.
Yeah, it's a big idea.
It sounds like we've gone from the abstract world of partitions to a very concrete application, with implications for cryptography.
Absolutely.
Computer science, all sorts of fields that rely on prime numbers.
You're absolutely right. This discovery is still in its early stages.
Right.
But it has the potential to revolutionize the way we think about prime numbers and their applications. And it all stems from the work
it all goes back
of a self-taught prodigy from India who claimed his insights came from dreams.
It's a truly remarkable story.
It is.
We've gone from rural India to the hallowed halls of Cambridge.
Yes.
From rediscovering a lost mathematical gem to uncovering new connections in geometry.
Right.
And now to a groundbreaking formula
I know.
that could reshape our understanding of prime numbers.
What a journey.
What a journey.
And it's not over yet.
There's more.
There's more. There are still so many unanswered questions. So many avenues to explore. You know, Ramanujan's legacy reminds us that the world of mathematics is vast, interconnected, full of hidden pathways waiting to be discovered.
It's almost as if Ramanujan, with his talk of divine inspiration, was onto something.
Right.
Maybe there is a kind of cosmic code embedded in the fabric of reality. And mathematics is the key to deciphering it.
What do you think?
Yeah, it's a profound thought, and one that definitely makes you think as we explore all this, depth of Ramanujan's work.
Absolutely.
But before we get too philosophical, though, let's bring it back to that prime number formula we were discussing. This discovery seems like it has, the potential to change the game in a lot of fields.
It does, absolutely. It's still early days, but the implications are vast.
Yeah, like what are we thinking?
Well, think about cryptography.
Okay.
The foundation of online security, right?
Right.
It relies heavily on prime numbers to create secure encryption keys.
Right.
So a more efficient way to identify prime numbers would lead to more robust and unbreakable codes.
So we're potentially talking about like safer online transactions.
Potentially, yes.
More secure communications.
Yeah.
All thanks to a deeper understanding of these partition identities.
It all comes back to that, yeah.
That's incredible.
It is.
What other areas might be impacted by this?
Well, prime numbers are also fundamental to computer science.
Okay.
Particularly in areas like algorithm design and data storage.
Okay.
A faster way to generate and test prime numbers could lead to more efficient algorithms, faster processing speeds, even new approaches to data compression.
It's mind-boggling to think that something as abstract
I know, it's amazing, isn't it?
as partition identities born from the mind of this self-taught mathematician
over a century ago
could have such tangible effects on our modern digital worlds.
Right.
It really highlights that interconnectedness of knowledge, doesn't it?
It truly does. And, Ramanujan's story is a testament to the power of
what?
Pure mathematical exploration,
Yeah.
Sometimes the most unexpected discoveries can emerge from just the pursuit of knowledge for its own sake.
Yeah.
And then those discoveries can go on to have a profound impact on seemingly unrelated fields.
Yeah.
Yeah.
So as we wrap up this deep dive into the world of Srinivasa Ramanujan, what's the key takeaway? What can we learn from this extraordinary journey through mathematics?
I think there are several valuable lessons kind of embedded in Ramanujan's story.
Okay.
First, it's a reminder that brilliance can emerge from the most unexpected places.
Right.
Ramanujan's lack of formal trainings, it didn't hinder his genius.
Right.
In many ways, it fueled his unique perspective and his willingness to challenge those conventions.
So it's a powerful message.
It is.
For anyone who's ever felt like they don't fit into that traditional mold. Your unique background and experiences can be your greatest asset.
Absolutely.
Especially in fields like mathematics, where creativity and innovation are paramount.
The second thing is, Ramanujan's story teaches us the importance of persistence and a relentless pursuit of one's passion.
Yeah.
He faced rejection and skepticism early in his career, but his belief in his own abilities and his unwavering dedication to mathematics ultimately paved the way for his success.
It's inspiring.
And finally, it's a reminder that even the most abstract, theoretical pursuits can have profound real-world applications.
It's true.
Like the connection between Ramanujan's partition identities and the discovery of this prime number formula. It highlights the interconnected nature of knowledge and the importance of supporting fundamental research.
Beautifully put. We may not all be mathematical geniuses like Ramanujan, but we can all embrace the spirit of curiosity, the willingness to challenge assumptions.
Absolutely.
And the belief that even the most seemingly obscure discoveries can hold the key to unlocking a brighter future.
Couldn't have said it better myself.
And who knows, maybe there is a bit of Ramanujan in all of us.
Maybe.
Perhaps we all have a touch of that divine inspiration.
Perhaps.
Waiting to be discovered.
Yeah.
So to our listeners, keep exploring, keep questioning.
Yes.
And keep dreaming big.
Absolutely.
You never know what mathematical mysteries you might uncover within yourselves and within the world around you.
Absolutely.
Thanks for joining us.
Yes, thank you.
On this incredible deep dive into the world of Srinivasa Ramanujan.
It's been a pleasure.
Until next time.
Yeah.
Keep those mathematical minds engaged.